So below is the graph of f of x equals 1/10 times x minus 2 times x plus 1 squared times x minus 4 cubed. So the real roots of the polynomial, we can get them from our factors or we can get them from our graph, but they would be -1, 2, and 4. The multiplicity comes with the exponents on their factors. So x minus 2, what exponent does that technically have? It has an exponent of 1 when it's not written there. So 2 has a multiplicity of 1. -1 has an exponent of 2, so it has a multiplicity of 2. And 4, the factor with the 4 had an exponent of 3, so 4 has a multiplicity of 3. Multiplicity just technically means that this root comes up more than once, or twice, or 3 times. So what does the graph look like at each root? At -1, what shape does this make? It looks like a parabola, or the shape an x squared makes. 4 makes this shape. What do we know makes that shape? Looks like a cubic. X cubed. And if we look at just the part where it crosses at 2, that looks like a line, which is represented by an x. And if you notice, -1, its factored had a 2. It looks like an x squared. 4 had an exponent of 3. It looks like an x cubed. 2 had an exponent of 1, and technically x is an exponent of 1. Now the degree for this polynomial, we need to check first, is this written in standard form? No, remember, standard form doesn't have any parentheses, it just goes highest to lowest exponents. If we were to multiply this out, we would have x minus 2 times x plus 1 would be there twice, and x minus 4 would be there 3 times. So we would have 1, 2, 3, 4, 5, 6 x's, so the degree is 6. 1 plus 2 plus 3. And a way we can check this is, this degree is even. Are our ends going the same direction? We're probably on the right track. So let's look at another graph. Here we have the graph of x to the 4th minus 14x cubed plus 70x squared minus 150x plus 125. What are the real roots of the polynomial and their multiplicity? Well, it only touches the x-axis once at 1, 2, 3, 4, 5. So 5 is our root, and it has a multiplicity. We can tell its multiplicity by the shape that it makes when it touches the 5. So since it makes a parabola shape, we know it's like an x squared, so it has a multiplicity of 2. Based on the fundamental theorem of algebra, which we talked about last class, and remember that means that the degree of the function is the greatest number of roots that we can have. So since we have a degree 4, we know that this polynomial has 4 roots. Since the 5 had a multiplicity of 2, that counts as 2 of the roots. So if 2 of the roots are taken care of by the 5, and it doesn't touch the x-axis anywhere else, that means that the other two roots are complex. So the multiplicities plus the number of imaginary roots needs to add up to 4 roots. That's all for today. See you in class.